For the part B of question number 33, it's given that a spherical balloon of radius r subtends an angle of 60 degree at the eye of an observer. So let's see how is this spherical balloon going to subtend an angle of 60 degree at the eye of the observer. And let's get our spherical balloon first. Okay, let's say this is the spherical balloon, and so this spherical balloon is going to subtend an angle of 60 degree at the eye of the observer. Okay, let let's say our observer is here B, and this is the eye of the observer. So how is this balloon going to subtend an angle of 60 degree at the eye of the observer? So we have to take two diametrically opposite ends of the balloon, and so this is how the balloon is going to make an angle of 60 degree. So let's say this is okay. This is one tangent, and this is, let's say, another tangent from the balloon, and this is the 60 degree subtended, and let O be the center of the balloon, spherical balloon. So this is how the angle has been subtended by the balloon at the eyes of the observer 60 degree. And let's say this is our horizontal at the level of the observer's eye. Now, height of the balloon from the ground is, let's say, this is the height of the balloon from the center, and this is, let's say, H, or let me just keep it as it is. Okay, I have moved. Okay, this is, okay, so this is the height of the balloon from the center, from the observer's eye. Now, it's also given that the angle of elevation at its center is 45 degree from the same point. From the same point means from the observer's eye, the angle of elevation is 45 degree, and now this angle of elevation is 45 degree from the center. From the center, so this is 45 degree, and this is our figure. Okay, now if I join this with the contact point here, so this is the radius. This is also the radius, and we know that radius is perpendicular to the tangent at the point of contact. So let me give these points P and B, and let's say this point is Q. So this point is Q, and I'm going to raise this. Okay, this is how this question is represented as a diagram, and we have to show that the height of the center of the balloon, that is this OQ. So OQ, we have to prove that it's root 2 times R. So let's say OQ is H, let height, let's say OQ is equal to H. So that means we have to prove that height of the balloon, height of the center of balloon is root 2 times its radius. So that's what we have to prove. Okay, now let's get if this is 60 degrees, so that means this angle is 60 degrees, so these two triangles are congruent because these two are the radii of the same circle. These two are the tangents drawn from external point. This is common. So that means this angle is 30 degree. If these two triangles are congruent, so angle OB, let's say this is, I have given it B. So this is, let's say, Q, and this is R. Now OR, let's say this is OR. So OR is equal to H. Now angle OBQ is equal to 30 degree. And if you want, you can prove the triangle is congruent and then with the half of this angle because this complete angle is 60 degree. Okay, now this angle is 90 degrees, so that means this is the hypotenuse, and for this angle, this is the perpendicular and this is the base. Now, you can also write that OQ is perpendicular to BQ. Why? Because radius is perpendicular to tangent at point of contact. Okay, now, so if this is 90 degrees, so that means in right angle, the triangle OBQ, I can use R by hypotenuse, perpendicular by hypotenuse sine. So this is sine 30 degree, which is R by OB, and sine 30 degree. So sine 30 degree is R, which is R by OB. And if we cross multiply this, this gives me OB is equal to 2R. Okay. Now let's move on to the right angle triangle. So this is also 90 degree because this is the distance is the perpendicular distance. So we can say in right angle the triangle ORB. So in right angle triangle ORB tan 45. So this is tan 45 degree is equal to OR by BR. The tan 45 is 1. Now OR is the height, and okay, we are not going to use tan 45 years. Let's see if we can get OB involved. So this is 90 degree, this is hypotenuse, H, this is H. So H for 45 degree, this is perpendicular by hypotenuse. So I'm going to use once again sine 45 degree, which is equal to H by 2B. And sine 45 degree is 1 by root 2. This is H upon OP. If we cross multiply this, this gives me OB is equal to H into 2. Let's say this is equation 2. So from 1 and 2, we get from 1 and 2, we get 2R is equal to root 2 into H. And this gives H is equal to 2R by root 2 into root 2 by root 2, which gives 2 root 2R by 2. So I is equal to root 2R. Okay, so that's what we have to do. Height from the center is equal to root 2 times the radius of the spherical balloon. And this solves our part B of the question number 33. Let's move on to question number 34.